only 0.5% of the Earth's surface, but a home to over 4% of its population. 323 million, 5 times the population of France. Even more people depend on the products of agriculture and fisheries from these regions for their daily diets. And that's a problem. The world is changing, we all know that, but it's changing much faster in some areas than in others. River deltas in particular are facing a multitude of challenges. Sea levels and temperatures are rising, rainfall patterns shifting. Human populations in delta cities like Bangladesh are exploding. At the same time, fish populations are plummeting. Biodiversity is on the decline, hydropower on the rise. With all of this happening at the same time, it's difficult to know what the future will hold and how to prepare for it. That's where my thesis comes in. I'm building a computer model that will show the effects of all these changes on river deltas and illustrate their combined impacts. To achieve this, there are 3 steps. First, I had to pick a study area. Looking at all deltas worldwide at the same time might be interesting, but a tad too much work for a 3-year thesis. Instead, I picked a study area in the delta of the Mekong, Southeast Asia's largest river. Known as the rice bowl of the region, it's home to 22 million people and part of the largest system of inland fisheries in the world. Second, I had to build and train a computer model. This involves setting up a system of mathematical equations that links inputs such as water levels and temperatures to outputs such as the amount of fish caught and the size of the rice harvest. For this training, I used a variety of data. I analyzed a series of satellite images, I dug through heaps of measurements of water levels and temperatures, and I went to Cambodia and spent a few months wading through rice paddies, interviewing farmers. Now, training a model may sound abstract, but all it means is that I modify my model slightly on the basis of the data that I have until it is capable of reproducing the current situation. Once it has passed this test, I can move on to step 3, modifying the inputs and seeing how the outputs change. For example, I can ask the model what will happen if temperatures rise by 3 degrees, sea levels rise by 2 meters, and 3 more hydropower dams are built upstream. With this information, local stakeholders can make informed decisions so that delta communities can continue to prosper and the future look a little less uncertain.